9.5 hyperbolas. So when you look at hyperbolas, the general form of their equations is x squared over a squared minus y squared over b squared equals 1, or y squared over a squared minus x squared over b squared equals 1. Now, what do you see that's different with these from an ellipse? There's a negative. Okay? So if there's a minus, it's a hyperbola. You still have an x squared and a y squared, but there's a minus between them. So that's how you recognize the equation of a hyperbola. Now you'll notice that when, and we're going to look at this picture in just a minute, but if you look at the c squared down there, c squared is equal to a squared plus b squared. Again, it's the opposite of the ellipses. Remember, in the ellipse, c squared equaled a squared minus b squared. So now in my head, the way I keep this straight is these signs are always opposite. If it's a minus in the original equation, then it's a plus in the c squared equation. That's how I keep them straight. So let's look at what they look like. If I have x squared over a squared, then the first variable is always the vertex in a hyperbola. It's different than an ellipse. It's not whichever's bigger, it's always the first one. So this one is x squared over a squared. So, and we can pick wherever we want to put them. I'm going to put my a's at 4. So my vertices are going to be at a0 and negative a0. So those are both vertices. Now, we have this b squared, and in our ellipse we called it the covertices. And you'll see here in just a minute that they aren't even actually part of the final. They give us the shape of the final graph, but they aren't part of the final graph. So they don't even give these a name. But we'll kind of refer to them as covertices just because it gives us some way to talk about it. So since the b squared is under the y squared, I'm going to put it on the y-axis. So I've got the point 0, b. How far did I go? And the point 0, negative b. Now, in order to draw these correctly, you're going to take these 4 points and you're going to sketch a rectangle around them. It's going to go through each of those points. So one side is going to go through there. One side is going to go through the vertex. One side is going to go through my 0, negative b. And my last side is going to go through the other vertex. So you're going to sketch a rectangle from those 4 points. Remember, we took the square root of a squared, just like in an ellipse, and the square root of b squared, just like in an ellipse. Okay. So now here's the really cool part of these. You remember back when we did the rational functions, we talked a little bit about asymptotes. Anybody remember what an asymptote was? Okay, exactly. An asymptote is a line that your graph gets really close to, never actually touches, and never crosses. Hyperbolas have asymptotes. They always go from one corner of this box to the other. So once you've gotten your rectangle drawn, you're going to draw 2 lines, and these will be the asymptotes of my equation. Now these asymptotes always go through, when your center is 0, 0, they go through 0, 0. Now if we moved it somewhere else, they'd go through whatever that center is, but we're going to just do the 0, 0 one. So the center goes through 0, 0. So I'm going to write an equation of these asymptotes. Well, if you look at the equation, y equals mx plus b, because it's a line, what's my b going to be equal to? Where does it intersect the y-axis? 0, 0. So b is 0, right? So that makes it a pretty easy equation. If b is 0, so I get y equals mx, so all I have to do is figure out the slope of that line. Well, slope is rise over run, right? So let's look at our picture here. If I start at 0, 0, and I count up, my rise is going to go to whatever b is, right? So I count up to b. My run is going to be to over whatever a is. So this slope is going to be b over a. So y equals b over a. X is the equation of that line.
Miss Redmond, just to clarify, on these things, it's the same rule. The biggest number of the team is going to be the a squared or y.
No, this one with the ellipses, or the ellipses, the a is always the bigger one. With the hyperbolas, that's not true.
What is underneath B?
What is underneath b?
Yeah.
Oh, b over a. That's the fraction b over a. Because I went up
And
b
then X.
and then x. So b over a is your slope, and x. Okay. So now if I look at the other one, I'm going to go up b and to the left a. So it's going to be the same thing, only negative. Y equals negative b over a. X. So in this one, and it's a really good question, Callie, because it's one of the big confusing points. With an ellipse, the vertices, the a's are always with the first variable. Now, if it's the x squared, my vertices are on the x-axis, and so here's, you don't have to do a t-table, because since I know that it's going to intersect, or it's going to get close to these asymptotes for hyperbola, you can just sketch them. You don't have to do a t-table. Okay, and I wrote my asymptote equations in a really bad spot because I have to draw right over top. There is your hyperbola. If the x squared is first, if the x squared is the positive one, they're going to open left and right because the vertices are on the x-axis. Okay? So this always opens horizontally. The other one, I'm going to come back to the foci in just a minute. The other one, the y squared is positive, so then my vertices are going to be on, we'll make this one where the a is the bigger one. These are the vertices are going to be on the y-axis because the y squared is first. So this vertex is at the point 0, a, and the point 0, negative a. Now this extra b over to the x squared, that's going to help me draw my box. So I'm going to have the point negative b 0 and the point b 0. They're always symmetric. They always are centered around. They go the same distance left and right and the same distance up and down. They're always symmetric. Once you get those points drawn, you draw your box. So that each of those points is a center point of my rectangle. Then I draw my asymptotes. Make sure you extend them out past the rectangle. You can see where the arms of your hyperbola are. The difference over here is, since the y squared was first, that's your vertex. So it's going to open this way. the y squared is first, if it's y squared over a squared minus x squared over b squared, it's going to open up and down. If the x squared is first, it's going to open left and right. Okay, does that make sense? Okay. So, what have we found? The important parts are the vertices. If the x squared is first, the vertices are at plus or minus a 0. Our asymptotes are at y equals b over a times x, and it's always a plus or minus, because we have a positive slope and we have a negative slope. And now the foci, we haven't found them yet. Now the foci are on the same axis as the vertices, just like in an ellipse. And we say c squared equals a squared plus b squared. So I'm going to take the square root of c, and since this one is on the x-axis, it'll be plus or minus c0 for my foci. So it would be out here, negative c0 and positive c0. Now when I look at the y, the important parts of that one, if the y squared is first, my vertices are at the points 0 plus or minus a. My asymptotes. Now this time, when I count up to a vertex. So it's going to be, the rise is going to be a, the run is going to be b. So that'll be y equals plus or minus a over b x. And my foci are going to be 0 plus or minus c. So they're going to be inside 0, inside the hyperbola. On the same axis as the vertices. Okay, it's a lot to remember. There's a lot going on with hyperbolas. So let's do an example and see if that helps it make sense. Okay, has everybody got this part? Okay. By the way, reminder, notes are due Friday. And if you're not going to be here Friday, turn them in ahead of time, because I got to have grades in by Monday. So keep that in mind. Okay, so let's try this. Now, this part is the same. The standard form of a hyperbola has to be equal to 1. So when you say I see a y squared minus a 25y squared minus 4x squared equals 100, you look and say, okay, well that's a minus. It's going to be a hyperbola. So I need to get it equal to 1. So we're going to divide everything by 100. So I simplify. 25 goes into 25 once. 25 goes into 100 4 times. So I get y squared over 4. 4 goes into 4 once. 4 goes into 125 times. So I get x squared over 25 equals 1. So now remember, with the hyperbola, the a squared is always with the first one, always the positive one. So my general form here is y squared over a squared minus x squared over b squared equals 1. So if a squared equals 4, what's a going to be equal to? 2. So a equals plus or minus 2. So I go over here on my graph, go from 0, 0, and I go 0, 2, and 0, negative 2. And I know my graph is going to be opening up and down. Okay, so then I look here and I see if b squared is 25, what's b equal to? 5, plus or minus 5. So I'm going to graph those points. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And so I have 5, 0. Negative 5, 0. Draw my box. Okay, each of the sides of the box. Then once you have that box, draw your asymptotes. So they go through the opposite corners of the rectangle. And extend them. They go out past the rectangle. Now looking at this, is this going to be kind of a wide one or a narrow one? It's pretty wide to me because it's going to be going up and down. But it's going to be a wide one. Okay. So, well, at this point, we can go ahead and sketch our hyperbola. We've got the vertex here at 0, 2. So you get it close to that asymptote, but never cross it. So let's see. Our important things that we need to have equations or points for. Our vertices are at 0 plus or minus 2. Our asymptotes, we have them drawn, but we haven't written equations for them yet. It's y equals, okay, to come to the center, I go up 2, right 5, so it's going to be 2/5 x, and the one, just the negative slope, I go, start from 0, 0, I go up 2, I go left 5, so I have negative 2/5 x. So those are my two asymptotes. One thing I'm missing, I don't have my foci yet.
You're gonna have plus or minus on the slope, right?
Yeah, I wrote it in 2, but you could do a plus or minus. Okay, and then you have, last is foci. So for that, I need to find my c. So a squared is 4, b squared is 25. So I know that c squared equals a squared plus b squared. So c squared equals 4 plus 25. So c squared is 29. So c is plus or minus the square root of 29. So that's where that calculator is going to come in. If it doesn't come out nice, we're going to find a decimal. What is the square root of 29? 5.4? So plus or minus 5.4. Okay, so now we look over here at our graph again. Now, since my foci are on the y-axis, since my vertices are on the y-axis, my foci will also be on the y-axis. So I start at 0, 0. I go up 2, 3, 4, 5.4. And so I have 0, 5.4. And I go to 4, 0, negative 5. So my foci are 0 plus or minus. There's 2 points for the vertex, 2 points for the foci, and 2 asymptotes, one with positive slope, one with negative. Okay, that makes sense?
I don't understand. Why do you ever need to use the second equation?
What's that?
There's 2 equations.
Okay, we're going to do that one next. Okay, the second equation is going to be when it opens left to right. So everybody got this one? Okay, so here I have one already in standard form. But the x squared is first. That's the second equation. I have x squared over 36 minus y squared over 9 equals 1. This time, my vertices are going to be on the x-axis because the x squared is first. So this is my a squared and b squared. So if a squared equals 36, a is plus or minus 6. This time it will be on the x-axis because it's matched with the x. So you go to 1, 2, 3, 4, 5, 6, 0, negative 6. my b squared is 9. B is plus or minus 3. 1, 2, 3. At a point 3, 0. At a point negative 3, 0. And once I have all my a's and b's, I can draw my box. So right through those sides. And once you have your box, then draw your asymptotes. Now at this point, I have enough information to actually sketch my hyperbola. Which way is it going to open this time? Left and right. It's horizontal. Okay, now let's write down our important information. So we've got, yep.
0 and 3.
Oh, yep. You're right. I wrote them backwards. I'll fix them. Should be 0, 3. And
Okay, I'm sort of confused. Why are they going out?
because this right here.
Oh.
Okay? That's going to tell you whether it opens side to side or left and right. Okay? Okay. So, our vertices are plus minus 6 here. Our asymptotes okay, y equals, now in this one, I always like to go back to the graph to figure this, because otherwise I can't remember, is it a over b or b over a? But if you look at your graph, it's easy, because you start at 0, 0, you go up 3 over 6. So it's going to be plus or minus 3 over 6x, but we'll simplify that and get y equals plus or minus 1/2 x for my asymptotes. And then I need my foci. So my foci are going to be, come back up here, a squared plus b squared equals c squared. So c squared equals 36 plus 9. C squared equals 45. So c equals plus or minus the square root of 45. Was it? 7.7. 6.7. Okay, so plus or minus 6.70. Since the vertices are on the x-axis, the foci will be 2. So it's going to be just a little bit. You'll notice since it's a tighter curve, the foci are a little closer to your vertices. So let's see. 6.70 and negative 6.7. Okay? So that should be enough to get you through the graphing that you're going to do for today. Questions?
We'll see.